Welcome back to the BAE Network. I'm your host, Jeff You Betcha. Last week we had a special regarding the ASABE Student Design Team competitions with members of the Kansas State Robotics Team, Tractor Team, and Fountain Wars. We wish these young engineers success on their upcoming competitions. Today our segment will feature developing precision agricultural technologies at Kansas State University. But what is something being developed for precision agriculture that impacts you? Let's look at these facts. The USDA estimates that agriculture uses close to 80% of the freshwater source. In Kansas and Nebraska alone, nearly 30% of the harvested cropland is irrigated, totaling 11 million acres. In 2050, we have to be able to double the amount of food with basically the same amount of land, water, and inputs. What's the limiting factor? Water. Let's go to Albert in the lab to explain how plants use water. Albert, can you explain this?
You betcha, Jeff. Plants use lots of water. Plants absorb water through their roots for growth and transpiration. Plants transpire to stay cool through openings on their leaf surface known as stomata. These openings are influenced by the radiant heat on the leaf surface, increasing evaporation. The amount of water the air can absorb, known as humidity. The convective heat transfer from the leaf to the air. The amount of wind. The amount of available water in the soil. In the end, it is based on the stomata.
Okay, thank you. Let's go to Devin to explain how he's using thermometrics to measure canopy temperatures.
Thanks, Jeff. We're using thermal cameras for variable rate irrigation and rangeland management. Biological and agricultural engineers strive to develop sustainable systems for global food demand. Let me show you how. We install our thermometric system on unmanned aerial vehicles to monitor plant water needs. In this example, we are looking at pastured rangeland. White indicates hot and black is cold. We apply our thermometric legend, allowing us to see the temperatures of the shortgrass and tallgrass. We then look at the crop health according to the crop water stress index. 5 indicates a stressed plant, where 0 indicates an unstressed plant. In this situation, we see we could rotate our grazing patterns. We do the same thing for sorghum plants. We're able to apply our legend, we can see the temperatures of the sorghum, we can isolate the background to be able to visualize the temperatures of the pot as well as the plant, and we're able to look at the profile of the plant, looking at individual part components. And then we can apply our crop water stress index to see how much water we need to add to the stressed plant to bring it back to a unstressed level.
And that's all the time we've got. Remember, if the glass is half full, it's probably twice as big as it needs to be. This is Jeff You Betcha signing off. And good night and farm on.